Before we get started, let me also quickly introduce myself. So my name is Gerd Brücker. I'm from Austria and working as a data engineer and solution architect for a company called Pico, where we support our customers in building AI and data platforms in the Microsoft Azure cloud. Besides my work, I'm also doing a lot for the community, providing like my blog with information about Databricks and also the Microsoft platform, including Power BI. And I also develop some open source tools for the community in the area of Databricks, and also maintaining the official Power BI connector for the Delta Lake. Okay, so let's get into the session. We prepared a quick agenda here. First of all, I want to briefly talk about why I actually decided to do a session on that topic. And then we'll jump directly into how we can actually use Power BI in combination with Databricks, elaborate and discuss the different connectors, discuss advanced use cases, especially when it comes to big data, and in the end, do some conclusion and lessons learned from what we've heard during the session. So the first part is why we actually want to use Power BI in our architecture. So on the slide, you see a very common architecture where you have like different data sources that are processed into a data lake or a Delta Lake using Databricks, and in the end are visualized using Power BI. So I guess that's also something that you probably already came across in your organization or in your environment, that all the data that you're processing in your platform at some point has to be visualized. It can be common data warehouse and BI reports, but can also be visualizations for the output of your machine learning models, for example, or analytics. So like if you are already in a Microsoft Azure and Azure Cloud, there is actually only one real choice when it comes to reporting, which is Power BI. Hence the session, how you best connect your data lake, your Databricks environment, and Power BI. So yeah, visualizing the data that you're dealing with. Yeah, we want to show, so Power BI is quite powerful, and there are various ways how you can connect to your data and visualize it. I will just show like the different options that we have using built-in connectors and also the Delta Lake connector that I mentioned before. There's also some very common pitfalls that you probably come across, which are mainly related to performance and costs. Performance, especially in terms of query performance, especially when you're using direct query mode, and costs with regards to the cluster costs when connecting to a Databricks cluster. Because whenever you are running a report against a Power BI report against Databricks, using the Databricks connector, you always need to have a cluster up and running, which obviously can introduce some costs. And also, I want to share my best practices and guidelines that I have learned during the last days when implementing this setup at our customers. Okay, so let's have a look on how we can actually query data from Power BI and the different connectors. However, before we get started, there is one very important thing that you need to understand when working with Databricks or most other big data processing engines in the cloud. There is this concept of the separation of storage and compute, meaning that the data resides on the storage, and whenever you need to process it or ingest new data or export the data, you have to spin up a processing engine that does the transformation job or the processing, and in the end either writes the data back to the data lake or exports it to somewhere else. For all this, the cluster has to be up and running. This also applies to when you query data using Power BI. You want to access the data and you have to do it via the cluster. However, the data is also accessible even if the cluster is not running, because it still resides on the storage, it's persisted there. And you can obviously also connect to the data itself. And that's also something that I will show during the session. So having those those two areas like storage and compute, we also have the reporting layer on top. As you can see here, there are different ways how we can actually connect the data that resides in our data lake store to Power BI. It can be via the Power Query, which is Power BI's integrated processing tool, or you can have various other tools. For this session, we will focus on Databricks and the Power Query solutions. And again, before we get into more details, there is another important aspect that we need to be aware of, or that we need to understand. And this is the two different modes that we do have when implementing a dataset in Power BI. First of all, there is the input mode, which is usually the preferred way, because the data that you want to report on is actually persisted as part of Power BI. And also, when we load the data into this persisted state and this persisted in memory cache, the source, being Databricks, only needs to be accessed once. So it's usually that you have like a daily report or a daily processing job that that fetches the latest data at I don't know, like 6 in the morning, and then serves all the reports throughout the day without the need of having Databricks up and running. The other option that we have is so-called direct query, which basically means that every query that Power BI generates is actually sent to the Databricks cluster. Again, you need the Databricks cluster up and running, and you also need to be aware that even a very simple Power BI report can create a lot of queries. This can be like, at least for each visual, one query will be executed. Some visuals even execute more than one queries. And performance obviously can suffer if you execute too many queries against Databricks. Also, in terms of latency and responsiveness of the report, there's always some overhead when we actually have to send the query to Databricks and wait until we receive the results. So this will usually never be as fast and snappy as if the query can be served using the in-memory cache and the input mode. Okay, now let's have a look at the actual connectors that we can use. As of now, there are three connectors that would be viable options. The first two, the Spark connector and the Databricks connector, are quite similar. Both of them actually connect to the Spark cluster that Databricks or your Spark environment provides. And as you can see in this comparison matrix, there is actually no feature in the Spark connector that's not also covered by the Databricks connector. So basically, the Databricks connector is superior to the Spark connector, which is also the reason why we will keep focusing on the Databricks connector. The second type of connectors is the file and storage access connectors. As I mentioned before, due to the separation of storage and compute, your data actually resides on a data lake. And usually this data lake, for example, an Azure Data Lake Store Gen 2, can also be accessed directly using Power BI. So you can actually use Databricks, process your data, store it on the Data Lake Gen 2, and then access the results from Power BI directly from the Data Lake Store. There are some features that are not supported when using the file and storage access connector, which is obviously direct query, because you don't actually have like an let's say responsive or interactive interface against the data lake store. And also well, in general, the authentication works differently. That's not necessarily a bad thing, just something that to keep in mind. And obviously, every improvement that would come with the new Spark version is also not usable by the file and storage access because there is actually no Spark involved. But on the plus side, you do not need an actual cluster up and running all the time, which can save a lot of costs actually, or even simplify your architecture. Okay, so when you connect to Databricks and using the Databricks connector, you basically will present them with a pop-up that asks you to enter the server name and the host name and the HTTP path. There are some additional optional parameters for the database and fast evaluation. Fast evaluation basically means that the number of round trips between Power BI and Databricks, which is usually quite chatty, is basically reduced to a minimum. The default is true, so you actually don't need to change something here and can just leave it as it is. The second part that's also very important for the Databricks connector, it actually supports Azure Active Directory authentication. So if you use Power BI, you already have an Azure Active Directory account, which you can also use to sign into Azure Databricks. And you don't need to mess around with personal access tokens or anything else. You can just use your account using single sign-on for Power BI, for Databricks, and basically for everything else. However, you could still also use a personal access token. To get the information from the server, from the Databricks cluster, it's actually pretty straightforward. You just have to copy paste the server host name and the HTTP path, and that's it basically. Once you have inserted those fields, you can just click connect. If you have not authenticated yet, it will probably prompt you to enter your credential, like your username and password or the personal access token, whatever authentication method you want to use, and then it will present you with this table navigator, which allows you to browse the different schemas and databases that you have and also select the tables that you want. So that's pretty standard when it comes to loading data in the Power BI. So if you would connect to a regular SQL server, that the UI would be quite similar. Then once you have selected one of your tables, Power BI leaves you with all the options that you have in Power Query. So you can do additional filtering in all of the different columns using like an in filter or selecting just the values that you want. But you can also have like advanced filters using between or greater than, depending on the data type that the column is you're actually filtering. Besides those simple filters, you can also create transformations in Power Query on top of the data that's loaded from Databricks, which is super convenient. And most of the stuff that you can do in the UI, in the Power Query UI, is also pushed down to the Databricks cluster, which basically means if you define a filter on, let's say, the account key in this example, it will actually generate a SQL query for you that says select star from my table where account key equals 2 or equals 3 or equals 4. And so the amount of data that's actually transferred from Databricks to Power BI is already very limited. Yeah, when it comes to Power Query functions, there's actually currently 3 functions that are provided out of the box. So there is Databricks.contents, which is actually legacy. It still works and allows you to read data from your Hive catalog. But nowadays, I would actually recommend to use Databricks catalogs, which is also the default if you just select Azure Databricks from the known sources. The additional features that Databricks catalog supports is actually the support for Databricks Unity catalog, and also the query pushdown that I mentioned before. If for whatever reason the regular UI capabilities for filtering and transforming your data is not enough, or the pushdown is not working for whatever reason, you can also create a native query in Power Query in Databricks. For this, you can use the Databricks.query function, where you also specify the server name and the HTTP path, and then just enter a regular SQL query that's then executed on the Databricks cluster, and the results are returned. You have all the flexibility there, as you have in a SQL query in a notebook, and basically can do whatever you want. And you're basically you're sure that the query is always pushed down or executed on the Databricks cluster. That's it for the let's say interactive connectors that support also direct query. And now let's have a look on the file and storage connectors. So basically, Power BI supports a very wide range of storage services. Obviously, everything on Azure, being a data lake store Gen 1 or Gen 2, being a blob store, whatever. It also supports traditional HDFS file systems and also local storage. So if your data is stored on any of those storage services, you can basically access it. The only thing that you need to keep in mind is that whenever you want to exchange or load data from Databricks into Power BI, you need to make sure that the format that you specify when writing your Databricks table is also readable by Power BI, which means Power BI at the moment supports CSV, JSON, and XML, Parquet, and also Delta if you use the official Delta connector that I'll go into more detail later on. So if you follow this, then you can just visualize the results directly from the storage in Power BI. Okay, so what is the Delta Lake connector? Basically, Delta Lake itself is an open source storage format. It's very well described, and it's based on Parquet and JSON, and provides like a transaction layer on top of your Parquet files. So as the format, the Delta Lake format is standardized, you can actually read this Delta log that contains all the transactions, get information from out there, and find all the files that actually hold the data. And that's exactly what the Delta Lake connector does. Basically allows you to connect, or you provide it with the source part of your Delta table on the data lake store, on the blob store, and then pass the content of that folder into the custom function that is basically the Delta Lake connector. So in this example, as you can see on the screenshot, we are connecting to a Delta table that's stored on a Azure Data Lake Store Gen 2. You need to provide the path at the top, and then feed this table that contains all the files into the actual function. So if you download the Delta Lake connector, it's basically this fn read delta table function. It's a Power Query code. Then you can select the table that you want to feed into the function. And once you execute it, it actually presents you the results or the data that's stored in the table. That's the very simple. It's like the simplest example. As you can see, there is also like an additional optional parameter that you can provide, which allows you to further tune the way how the Delta connector works. Most importantly is probably that there is a way that you can use partition elimination, where you basically only read the files, or the files that are actually necessary to answer your query, like a specific partition. But you can obviously also use all the other capabilities like filtering and transformations from here on, as you can also do for the Databricks connector. Okay, let's have a look at some more advanced use cases. Those are especially targeted about reporting on bigger volumes of data or big data, where we basically need to use direct query for the simple reason that the data that you want to report on is too big to be loaded into memory. So there are a couple of features that help us to build data models that support those data volumes. And one of them is composite models, and the other one is aggregations. So composite models is basically a feature that allows you to have one data set that combines data from an input mode, which is in memory, and also from a second source, for example, that is in direct query. And then you can have like a table where the first column is sourced by the import mode, whereas the second column is sourced by the direct query mode. But they're both connected via, let's say, shared dimensions, which could be like a simple date table. Okay, and this gives you the flexibility that you can build one report and connect it to multiple sources and give the user the ability to combine them in the report. That's already quite powerful, but there is also an additional feature called aggregations, which make this even better. So aggregations basically allow you to store an aggregated table inside the data model and make the Power BI engine choose automatically which table should be used when answering specific queries. So if the Power BI engine realizes that a query can be answered by using the data in the aggregated table, it does not need to touch the detailed data. For example, let's assume we have like sales data on a store and on a date level, which would be all my details. Let's assume it's a couple of billion rows in my details table, and I have an aggregation defined for a store and date on top of that detail table. If I create a report that only queries data for a particular date, the Power BI engine would be smart enough, knowing that it can answer that particular query by only reading data from the aggregated table. Because it can aggregate this data into the final result. If you add, for example, an additional attribute which is not covered by the aggregation, the engine has to go back to the detail table, which would usually be direct query and is not part of the input mode and is much slower, therefore. So, and that's already the combination of the composite models and aggregation. So the detail data is in direct query and is only used if the report actually accesses the detailed data, and everything else on aggregated level can be held in memory because the memory footprint is not as big for the aggregated data. And the data model is therefore much smaller because it does not contain all the detailed data and is therefore much faster. But still gives you the ability to do like a drill down to the detail rows within the same report. The second feature, or the third feature actually, that also is targeted towards big data processing is so-called hybrid tables. It was just recently introduced at the Build conference in May. And it basically allows you to also combine input mode and direct query, but not on a table level, but already on a partition level. So means you can have one table with multiple partitions. Usually you have one partition, let's say per day or per month. And now you can decide whether you want to have a partition in input mode or in direct query mode. Very common use cases for this is if you want to have archived data or very old data, let's say it's 2 years old and it's only used in a very few reports or very specific use cases. You can leave it in direct query, meaning it has no impact on the common reports that target more recent dates, but still give the user the ability to just change the date of the analysis back 2 or 3 years and still provide data. The performance will be much slower, obviously, but that's usually acceptable because the people know that the report is optimized for, let's say, the most recent periods. The second use case where this can be quite important is for real-time use cases. So let's assume you have a table in Databricks where you stream into, like every like a constant stream, so the data is actually always changing, and you need to always show the latest data in your Power BI report. Usually there is two options that you can use. You can process that latest partition every 5 or 10 minutes. Much less doesn't really make sense. Or you can use direct query mode, which means, again, whenever you update your report or refresh your report, it's actually querying the Databricks cluster directly and retrieving the most recent data from there. That all sounds super cool and really nice, but you have to keep in mind that there are some limitations when it comes to direct query in general. Those are especially about so-called calculated columns, which is a really nice feature in input mode. But in direct query, they are quite limited. So you can actually only use them to process data that is already in the same row, similar to running a transformation in a SQL query without having any joins. You can just like access data from the very same row. The other limitations are some specific DAX functions only work, or well, do not work with direct query. Those are mainly related to time intelligence, but also others. So just make sure that if you want to use direct query, also the DAX functions that you may already use or want to use are also fully supported. Another thing that you need to keep in mind is that hybrid tables are still in public preview as of June 2022. But actually, I expect them to be GA, let's say in Q3 or latest Q4 of 2022. Whenever you access data from Databricks, regardless whether it's via the Databricks cluster or via the file connector, you should always keep in mind and be aware how the data that you want to access is partitioned. Because partitioning is probably the most important part when it comes to performance. Just prepared a very little and very simple example. So let's say you have like one table and you query by the sales territory key, which is also the column that the table is partitioned by. It's very easy for the engine to retrieve all the data that needs to be accessed to answer the query, because it can just go into the sales territory key equals 5 folder and take all the data and parquet files from there. All the other ones, it already knows upfront that they are not relevant for the query. However, if you would write a query that's not optimized or that's not aligned with the partitioning columns, you would actually need to scan the whole table in order to find the rows that are necessary to answer your query. As you can imagine, if you have a big table that's multiple terabytes or even petabytes, that just doesn't work usually, right? So you always need to be aware what those partitioning columns are and how to use them. Okay, now the last part, conclusion and lessons learned. Okay, as I have shown, we do have multiple ways to connect the Databricks. It's basically the Azure Databricks connector and the Delta Lake connector, or the file connectors in general. If you're using Databricks, you probably also use Delta Lake. So I would not really use any other connector than the Delta Lake connector when I actually access the data lake directly. When it comes to selecting which connector to use, the Databricks connector or the Delta Lake connector, there are some simple heuristics that you can use. If you do have any complex logic in your SQL query that you need to be processed, especially when it comes to joins. So if you join two big tables, for example, you should definitely use the Databricks connector. The Delta Lake connector works fine for smaller amounts of data, and if the data is already very well prepared, let's say, and you don't need to do a lot of joins. Ideally, none at all. Because if you want to do a join, you need to load the data into Power Query engine first before you can actually do the join and process the data. Okay. Another reason, very good reason to use the Azure Databricks connector are the advanced features that I mentioned before. So if you want to use composite models, aggregations, or hybrid tables, they basically all require direct query, and direct query is only available in the Azure Databricks connector. So if you have a very big data model in Databricks, or a very big table, which you cannot load into memory, you need to use direct query and therefore Databricks connector. Yeah, Delta Lake connector, as it says on the slide, it's input mode only, so there is obviously no direct query. If that's fine for you, I would still recommend the Delta Lake connector. Main reason actually being that you do not need to have a cluster up and running all the time. Okay. One thing that I did not mention about the Databricks connector, and you probably ask yourself how it is working. What actually happens if you run a query against a Databricks cluster that is not running is that Databricks starts the cluster and then answers the query, which means that you have at least 10 minutes overhead or until the cluster is started up before your queries actually get answered. That's also just something that you need to keep in mind. But you don't need to explicitly start the cluster on your own before you can use it. So you can just start a query, wait for those 5 to 10 minutes, however long it takes, and then you're ready to go. Some other best practices, not only related to Databricks, but to Power BI in general, is to use views. So you can already prepare some of your business logic or reporting logic in views, which has the very big advantage that you can reuse those views and the reporting logic in multiple reports. Okay. If the logic in the view is too complex and it takes too long to evaluate the view, you can also persist the result of the view as a pre-calculated table as part of your ETL pipeline and data pipelines. But it's a very easy and neat way to have and maintain all the business logic in one place. The other much worse case would be that you have most of the business logic in Power BI, and whenever you want to debug something, you need to open Power BI and redo all the different processes in Power BI. If for whatever reason you cannot create views in Databricks, you can obviously still use Power Query to for example, do some filtering or creating aggregations or whatever you want. So Power Query is also quite powerful there. But again, if you have business logic that should be reused across multiple reports, you probably do not want to implement it over and over again in Power BI and Power Query. So it's just not like a good design. If you decide to use Power Query for your transformations and processing, please make sure that the query, first of all, is pushed down to Databricks. You can check this if you go to the Spark UI and the SQL parts and see what query actually is executed. And what you definitely want to achieve is that at least all the filters and projections are pushed down to Databricks so that no unnecessary data is transferred between Databricks and Power BI. However, still always keep in mind or be aware of the data volumes that you're processing and that you're loading. especially because Databricks is usually used for big data processing, and there you can easily have tables with, I don't know, hundreds of terabytes or petabytes. And as you can imagine, you do not want, or it's technically not even possible to load one terabyte or 1 petabyte into a Power BI data model. Next to that, know your partitions. That's probably the most important thing that you should take away from this session. Whenever you deal with data from Databricks, data is partitioned usually, and if you write a query that doesn't hit or is not aligned with the partitioning of that table, it can potentially be very slow. And ideally, the data or the table is at some point already prepared and aligned with the most common query patterns that your reports will use. If that's not the case, you should probably talk to the people that implement the table in Databricks, and ideally they can change the partitioning scheme so that it matches your query patterns. And the last part is only related to the Databricks connector, obviously, because it's about the cluster, the size, and the node types, and in general, the whole cluster configuration. So there are specific cluster types, especially the storage optimized ones, that are preferable because they have like SSDs and cache on the nodes themselves and do not need to access the data lake and load the data from there each and every time you run a query. So that's probably the most important part for the cluster setup or the cluster definition. The size, well, very much depends on the data volumes that you want to load and also on the performance that you need and expect. So yeah, you probably need to play around a bit with the different sizes and node types, but I'm sure you will end up with a good configuration of your cluster. Okay, that's it. Thank you very much for your attention and our only support for those scenarios that we described in the session. Feel free to just reach out to me and drop me an email or contact me on Twitter. I'm happy to support whatever you